How we doing, guys? We are looking at an idea called proportionality here. Um, if this is your age and your pocket money is allocated to you according to your age, if you're 10 and you're getting €5, 11, 5.50, 12, 6, you can probably spot a pattern here. There's a rule that your pocket money, which is your output in your function, y, is one half of your age. So one half of, sorry, x is your input. Okay, so there's two ways you could write that. Y is a half x, or you might say pocket money is a half of your age. Okay, but this is how a lot of the time in maths we'll write something like this. If you're to plot that out in a graph, there's your 10-year-old who's getting a fiver for pocket money, which is more than I ever got. There's 12-year-old getting €6 and a 14-year-old getting €7. What you find is there's your 11-year-old getting 5.5, and your 13-year-old getting €6.5. They line up in a straight line. This is called a linear function. And what's more, if you continue on that straight line, it goes through this point 0, 0, also known as the origin. So a straight line through the origin suggests proportionality. Proportional means the rule can be written as y equals something multiplied by x. Okay, I'm just going to say k for that something. So that might be a half, it might be 5, it might be 12. That's called a constant of proportionality. And if you plot it out, you will always get a straight line through the origin. Okay, you'll always get a straight line through the origin. Okay. One of the things you can do then is use that to predict, well, what happens, for example, if you have a 17-year-old, how much pocket money will they get? Well, according to our rule, or this rule here, let's say, y will be one half of 17 is the age you plug in. So you can make predictions once you have a rule like this. A proportionality rule. What's half 17? €8.50. Right. Looking at question 2 on page 468 here, the graph shows the relationship between kilometers and miles. It's a straight line, it goes through the origin. So this is a directly proportional relationship, which is the last question to be asked. Is the graph a directly proportional one? Yes. Why? Because there's a straight line through 0, 0, or through the origin. Use the graph to convert approximately 60 kilometers to miles. There's 60 kilometers. There is roughly, well, that's 30, 35, so somewhere between 35 and 40 miles. Let's say 38 miles. 80 kilometers to miles, there's 80 kilometers, falls right on the nose there on 50 miles. 30 miles to kilometers, so come up here to miles, 30 miles converted to kilometers. It's down here, somewhere between 45 and 50 kilometers, so let's say 48 kilometers or 47 and a half. 15 miles to kilometers, there's 15 miles there, converted, you get somewhere between 20 and 25, that's maybe like 24 kilometers. Is the graph directly proportional? Yes. Why? Because it's a straight line through the origin. Question 4 says television charges depend on the length of time taken for the repair as shown. A few things to point out. First of all, we're no longer going through the origin. This is still a straight line relationship. It's called a linear relationship, but it is not a proportional relationship because you can't just multiply the time by some number to get the charge, like we could with pocket money. What is the charge for a repair that took 60 minutes? There's 60 minutes cost €70. For a repair that took 30 minutes, somewhere between 50 and €60, let's say €55. If the charge was €80, how long did the repair take? There we go, 80 minutes. And if the charge was €60, how long did the repair take? 40 minutes. The standing charge is the basic time for the charge before it's added. What is that? Well, that's if you had 0 minutes, you'd still have to pay €40 just for dropping the television into this shop. Okay, just this little jag here, jaggedy bit, is where you've jumped from 0 to 40. You're not going up in an even scale there, so they're just showing that explicitly on the graph. Now, they don't ask for this, but you can come up with a rule for how much you're going to be charged for the television as well. Okay, and seeing as we've just finished coordinate geometry, it should be manageable enough to do. If you look at this point here, 0, 40, and this point here, 80, 80, you can take a slope off this graph. Okay, there's a rise over run. Okay, your rise goes from 40 to 80, that's a rise of 40. Your run goes from 0 to 80, that's a run of 80 minutes, a rise of 40 euros. Okay, your y-intercept here is at 40. Here's that graph drawn out. So a rise of 40 euros, a run of 80 minutes means that the shop is charging 40 euros for every 80 minutes. That's the same as €0.50 per minute. Okay, now that's the slope of the graph. As I've said in previous video, I think it's also a rate at which you are charging. So slopes and rates are very closely related. If I want the equation of that line, well, y equals mx plus c, if you remember from coordinate geometry, m is the slope, which we now know is a half, and c is the y-intercept, which you can see over here is 40. So that equation is y equals 1/2 of x plus 40, or y represents the cost is 1/2 of the time plus 40. Okay, so that's your rule for working out how much you're going to be charged for the television. And if you can do that comfortably enough, that's a pretty useful skill to have. Okay, so that's your coordinate geometry, that's your rule, but really you're looking at the same thing here. We'll finish then with question 7. The graph shows the cost of using broadband internet for 1 month on 3 different plans. The 3 plans are rental of 30 euros and 10 cents per gigabyte. Okay, so that's this red line, y-intercept of 30. So your initial cost is always your y-intercept at 30. 10 cents per gigabyte. Well, if you check the slope on that, from here, 45, that's a rise of 15 and a run of 0 to 90. So 15 over 90 is your slope, which is the same as 10 cents per gigabyte. No rental, but 30 cents per gigabyte. Okay, that's here, the green line, y-intercept at 0, slope of, excuse me, that's 100. So 15 over 100. It's 15 cents per gigabyte in that first one. Sorry about that. Here, 30 over 100 is 30 cents per gigabyte. And the last one, the rental, our basic cost of 37.50. 5 cents per gigabyte, but with the first 60 gigabytes free. So you can see here your slope is 0 for the first 60 gigabytes. And then you've got a much shallower slope because you've got a smaller 5 cents per gigabyte. So that's your, I suppose, how these relate back to coordinate geometry. Carl downloads more than 140 gigabytes of data each month. Which tariff will be the cheapest for her to use? So she's here, 140 gigabytes per month. The green one, okay, tariff number 2 would be her best bet because it gives her the cheapest one. But if it's more than 140 gigabytes, you'd have to go a little bit beyond. You'd say probably the blue one is the better option. If she's gone anywhere over 142 or 143 gigabytes, probably tariff C would be the better option. Okay, I'd ask you to go now and have a look at page 468, question 3 and question 5, 468 to 470. Okay, thank you.